Hi, I'm Gidon from thetechnologyman.com. The Creality K1 Max is one of a new breed of fully enclosed, super fast 3D printers. It comes pretty much ready assembled and requires almost no setup. It has Wi-Fi, Ethernet and a webcam built in, which makes starting and monitoring prints extremely easy. It uses its webcam and a LIDAR sensor for a number of AI features intended to improve print quality and reduce failed prints. I'll run through its features and thoroughly test all of Creality's marketing claims to see if this is the right 3D printer for you. So let's take a closer look. The printer comes almost completely assembled in a large box. Creality has a useful unboxing and setup video on their YouTube channel that I'll link to below. But all you need to do is peel off a lot of protective plastic, install the door handle, attach the LCD screen and filament spool holder, install the damping rubber feet, and most importantly, remove the 3 bolts that secure the bed in place during transportation. Creality supplies some useful accessories that you can see on screen, and it's the first printer I've reviewed that is supplied with a full spool of their Hyper PLA high-speed filament in the box. There's also a complete spare hotend, which is a nice touch. This initial assembly takes less than 30 minutes, and you're then ready to turn the printer on to finish setup and start your first print. The LCD screen reminds you to remove the 3 bed fixing screws and then prompts you to connect to your Wi-Fi network. There's also a built-in Ethernet port if that's easier for you. I'll skip the binding to Creality Cloud. You're better off doing this later when you're all set up. The printer does a self-inspection to check everything's working okay, and then runs through its input shaping and auto-leveling routines. The input shaping calibration will vibrate the print head at varying frequencies. There'll be noticeable vibrations at its resonance frequencies. The printer will use these measurements a little like active noise cancellation in headphones, to reduce printing artifacts caused by vibrations you'd otherwise get at fast printing speeds. It's a good idea to have the printer on a solid table for these measurements. And you'll need to repeat this calibration if you move the printer. Bed leveling probes the large printer bed using a 6x6 grid, a total of 36 measurements, to account for any unevenness. But on top of that, the K1 Max can measure the Z offset, the exact height the nozzle sits above the bed for the critical initial layer. This normally has to be done manually, usually sliding a piece of paper between the nozzle and bed at various locations. It is one of the hardest aspects of 3D printing for a complete beginner. I'll discuss how this all performs shortly, but the whole process takes around 10 to 15 minutes and you're ready for your first print. Like the K1 Max is built around Klipper, a powerful open source 3D printing firmware with many advanced features that can significantly speed up printing speeds. In the case of the K1 and this K1 Max with their so-called Core XY design, Creality claims speeds up to 600mm per second with a 32mm cubes per second high flow extrusion system. That's considerably faster than your traditional 3D printer like the Prusa MK3S Plus and even Prusa's latest Mark IV. With these so-called bed slinger 3D printers, the bed moves backwards and forwards for the Y-axis. With a Core XY printer, the print head moves along both the X and Y axes. In both cases, the bed moves up and down the Z-axis on threaded rods. But Core XY printers have this flipped on its head, with the bed moving towards the print head rather than the other way around. The K1 Max has a large 300 by 300 by 300mm build volume, compared to 220 by 220 by 250 for the K1. With its Core XY design, its footprint is actually less than my Prusa Mark III with its substantially smaller 210 by 210 by 250mm build volume. You can see its dimensions and weight on screen. It's the best looking printer I've reviewed so far. Even my wife, who has zero interest in any of this, thought it looked impressive. And it's well built with a die-cast aluminium frame and glass door and lid. The glass and perspex side panels have an attractive black tint. Although when it comes to its performance, I'll mention a few more hidden areas where costs have been cut. The printer is powered by a dual-core 1.2 GHz processor and has 8 GB of built-in storage, enough for around 400 models. It has a 4.3-inch colour touchscreen, and you can also control the printer via a web interface. The LCD screen is nice and responsive. The home screen lets you set and monitor the temperature of the nozzle and bed. You also get quick access to control the fans and can turn the LED on and off. During a print, this shows the print progress. The prepare menu lets you control the movement of the print head, extrude and retract filament, and the same fan control menu we just accessed. I'll discuss the file menu shortly, and you can see the various configuration options you have under the settings menu. The last menu is the support menu, which is pretty self-explanatory. The K1 Max comes with a camera and LIDAR sensor built in that I'll cover shortly. Both are optional accessories with the K1. It comes with a smooth flexible build plate, but a textured PEI sheet is available as an optional extra, which I also tested. It has a direct drive setup with the extruder sitting directly above the hotend with a hardened steel 0.4mm nozzle, although this can be swapped with a 0.6 or 0.8mm nozzle. The hot end can reach temperatures of up to 300 degrees centigrade and the heated bed 110 degrees centigrade, so it should be able to cope with some more advanced plastics. Filament is actually fed through a PTFE Bowden tube from the rear of the printer to the extruder, a sort of reverse Bowden setup. Loading filament is not very well detailed by Creality, so I'll quickly cover the process. Remove the lid and set it to one side for this first PLA print. Move the extruder lock arm to the unlock position, load filament on the rear spool holder, cut the end of the filament at 45 degrees and push it up through the PTFE tube, through the filament runout sensor, all the way to the extruder until it won't go any further. Move the extruder lock arm to lock position. From the LCD screen, tap on the prepare icon, then extrude, retract. Choose a printing temperature of the filament you'll be using, 220 degrees centigrade for the supplied Creality Hyper PLA filament, and tap extrude. The hot end will heat up to 220 degrees centigrade and then extrude filament out of the nozzle. You may want to do this a second time, especially for changing filaments. Now you can send your first print. I reckon without filming this whole process, it'll take around 1 hour to get to this point, which is pretty good. From the home screen, tap the folder icon, and from the default local tab, select the 3D Benchy model. Here there's also a ready sliced freestanding spool holder and a calibration cube. From the USB drive tab, you can also access files off a USB stick. And in history, you can browse through completed prints. Back in the local tab, tap on the 3D Benchy again, you'll see a thumbnail of the print, check everything's okay, and hit print. Only send this pre-sliced model if you have Creality's Hyper PLA filament loaded. The printer kicks into action, and all being well, you should have your first print in around 16 minutes. This is a lightning fast print and shows off the full capabilities of the printer. But typically you won't be printing this fast. You can remove the flexible plate from the magnetic bed and bend it to release the model. This is one of the quickest 3D Benchies I've printed. Although it's hard to tell in white PLA, the quality is more than acceptable. There are various ways of sending prints to the K1 Max. If you have the printer connected to your home network via the Ethernet port around the back or its built-in Wi-Fi, you can send files directly from your computer. There's also a USB port around the front if you prefer. Creality wants you to use their Creality Print Slicer, which I thought would be a very painful experience. But it's actually improved a lot recently and it's now very usable. And some of the advanced AI features of the K1 Max require the model to be sliced with Creality Print. The software can automatically scan for your printer on your local network and add it as a device. Creality Print has a simple user interface, and if you're using Creality's Hyper PLA, there are built-in profiles that work pretty well. There are also generic profiles for PETG, TPU, ABS, Polycarbonate and several other filament types, which is great to see and provides at least a starting point. I've tried many of the profiles and will discuss how they fared shortly. I printed the same Benchy, this time slicing it in Creality Print. Even with a 0.2mm fast profile, Creality Print estimated 31 minutes, almost twice the time it took from their hand-tuned pre-sliced Benchy. The quality was a little better though, and 31 minutes is still pretty quick. Encouraged by my initial prints, I went straight for a larger print that uses a good portion of the bed. Any print I discuss I'll link down below in the description. This cable management box I printed with white Hyper PLA directly from Creality Print. I again sliced it using their 0.2mm fast profile. According to the slicer, this would take around 4 hours to print. This model just fits on my Prusa MK3S Plus, but will take around 14 hours with Prusa's 0.2mm speed profile. After you slice the model, you can select land printing, which takes you to the device page. Here you can select your printer and send your print straight across to start printing. If you have multiple printers, perhaps a print farm, you can send the same file to multiple printers at the same time. Send G-code just sends a file across. You then print it via the printer's LCD screen under local files. Or you can choose one-click printing, which will upload and start the print immediately. The device screen monitors the print progress, but if you tap on details, you'll see a live image of the printer with lots of additional information. You can directly control the printer here too. One thing you can't do either here or on the printer itself is adjust the Z offset if you find the automatic setup isn't good enough for you. You can set a Z offset in Creality Print under experimental enable G-code offset, but that's not ideal. But Creality has recently enabled root access to the printer, which means you can install your own web interface and live adjust the Z offset and much more. I'll show you how to do this shortly. It's pretty easy. The webcam feature is brilliant. It's perfectly set up to see the whole bed, and there's just enough light from the printer's built-in LED to see print progress, even with the room not lit. Although a few more LEDs would have been nice. What's more, without any setup, the printer records time lapses of your prints, which whilst only 720p still look pretty good. You can access these time lapses in the details screen right in the Creality Print application. Look at the File section and click on Time Lapse Video. Click on any print and select Export. Although you need to use Creality Print for some of the AI features, you can slice a 3D model in any slicer, including Cura, Orcaslicer or Prusa Slicer, and then upload the file directly to the printer via a web browser. You don't even need Creality Print installed. Just type in the IP address of the printer, which you can find under Settings, Network, into Chrome or any other web browser. This interface is almost identical to the one in Creality Print, but also shows a bed level mesh, which I'll come back to. Without a fairly complex configuration of your router, you can't access this IP address outside your home network, which can be very useful for longer prints. However, if you bind the printer with a Creality Cloud smartphone app, this app does let you monitor prints remotely away from home. Tap on Settings, bind to Creality Cloud on the LCD screen and select your region. Download and install the Creality Cloud app and tap the scan icon in the top right to connect your printer to the app. Now under Workbench, you can monitor and control a print wherever you are, even over a cellular connection. This works via a web browser too if you go to crealitycloud.com. I had mixed results with this. Sometimes it worked, sometimes it didn't. And even when it worked, I didn't always get the webcam video. Also, the Creality Cloud app is painful to use. It's plastered with advertisements unless you pay for a premium subscription. As I publish this video, you do get a free 1-year subscription to the premium plan with purchase of a K1 Max or K1, but it took me a while to figure out how to enable it. You need to copy the ID of the printer into the activation page that I'll link to down below. You can get this ID from the Workbench tab in the smartphone app, just tap copy. Currently I certainly wouldn't pay for premium and it's not cheap. As well as getting rid of ads, there is a selection of prints to download included in your subscription, but it's very limited and mostly geared towards resin printers. Hopefully this will improve by the time your free year is up. If the remote monitoring becomes more reliable, I'll use the app more. This cable management box did complete successfully in under 4 hours and looks okay. It's by no means perfect, but for a functional print it is acceptable. I also had the printer on a fairly wobbly desk for these early prints. I soon moved it to a more stable workbench. The lid finished in 1 hour 30 minutes and fits the box perfectly. This box was a good test for the completely automatic first layer calibration. In some areas I could have done with raising the Z offset slightly, but I didn't have any problems with prints sticking to the bed. At this point I thought I'd try some of the AI features of the printer to see if they offered any improvement. There's lots of marketing over these AI features, but in practice they're hidden away, poorly explained and not even enabled by default. You need to go into Settings, Camera, AI function and check the features you want enabled. You also need to make sure you select print calibration, otherwise the flow and pressure advance measurements and first layer detection will be skipped. I tried several prints with all these features enabled, making sure I slice with Creality Print. The foreign object detection, which uses the camera to check the bed before a print commences, does sort of work. It's most useful if you've gone to start a print and forgotten to remove the previous one. This picked up most moderately sized objects if they had good contrast against a black bed. This black 3D Benchy wasn't picked up, so I wouldn't rely on it just yet. The camera is also meant to be able to detect a failed print. I only had one failed print with this feature on, which it didn't pick up, but again I was printing a dark filament. The LIDAR sensor is meant to be able to calibrate the flow rate and pressure advance values, which will vary with every filament. It prints a few zigzag lines and then scans them with the LIDAR sensor. I printed a few calibration cubes with this on and off and couldn't notice any difference. The first layer detection feature also uses the LIDAR to scan the first layer of a print to identify any issues. I'm not sure exactly what issues it's looking for, but I was hoping it may be able to do some fine Z offset tuning, but it didn't. The LIDAR scanning does look very impressive, but after testing it I turned all these AI features off. They don't appear to do much and take a fair bit of additional time. I am hopeful though these features will be developed further in the coming months. One thing I haven't mentioned yet is the noise this printer makes. There are no less than 5 fans. There's a fan to cool the electronics in the base of the printer. There's an extractor fan which is useful for printing filaments like ABS that emit unpleasant odours. This fan passes through a carbon filter around the back of the printer. Then there's a hotend fan and 2-part cooling fans to improve print quality printing at high speeds. One on the front of the hotend and the other one on the right side of the case. The huge 18-watt side fan is also used to quickly cool the nozzle down during calibration and the various nozzle cleaning cycles, but it is very noisy at full output. It sounds like turning a rapid boiling kettle on. With all the fans on, you can hear the printer in the next room, even before the head starts moving around, which at high speeds also sounds noisy. I measured 80.4 decibels with a sound level meter 1 meter away and with a glass lid off. It's a little quieter with the lid on. I measured 72.6 decibels. I've been trying to work with the printer running in the same room and it is difficult. You really need ear defenders, printing PLA at least. Printing ABS and PETG with the side fan off and the lid on, it is quieter. And with smaller models with shorter travel moves, you won't reach those maximum sound levels. Creality suggests you need their Hyper PLA for fast prints, but I tested the pre-sliced 16-minute 3D Benchy with one of my favourite filaments, eSun PLA+. Changing filament is fairly straightforward. You go back into the extrude retract menu and tap on retract. You'll remember your last temperature setting for loading the filament. When it's finished its routine, push down on the white collar to release the PTFE tube and carefully pull out the filament. Then pull the filament out of the PTFE tube and wind it back onto the spool. Push the PTFE tube all the way back in, it's self-locking. You don't have to release the PTFE tube, but the end of the filament has a very thin neck that can easily get left behind in the extruder, so I find this way safer. The Benchy printed fine in this red PLA Plus and looked almost identical to the white Hyper PLA print, which is a relief since Hyper PLA is only available in a few colours. Next I tried a print that covered pretty much the whole build plate, this foldable crate, this time in grey Creality Hyper PLA. I could print all parts in one go, something not possible on a smaller printer. The first layer again stuck well but looks a little rough, which could be improved with a flow calibration test, which is built right into Creality Print under the calibration menu. This flow rate test is worthwhile if you notice any under or over extrusion. There's a tutorial guiding you through the test. My daughter wanted one of these prints in pink, which gave me a chance to try this matte or silk PLA, again from eSun. Creality has a silk PLA profile which slows things down slightly, and this print also came out pretty good. And I have had difficulties printing this filament on the Creality S1 Pro. It doesn't always stick too well to the build plate. I did plenty more PLA prints and they all came out okay with no failed prints. Creality do recommend keeping the lid off for PLA prints if your ambient temperatures exceed 30 degrees centigrade. This is to prevent heat creep, which can cause nozzle clogs. We barely see these temperatures here in the UK. I did mostly keep the lid off anyway for printing PLA. There's no way to store the lid, so I printed these storage brackets which attach to the side of the printer. You'll need some slightly longer bolts, the existing bolts won't reach. This drawer that slides under the printer again tested the levelling and it came out nicely. It took almost 4 hours though. It covers most of the bed and the first layer still needs to print quite slowly for adhesion. Additionally, Creality has some very conservative settings for skin bridge speed in the Hyper PLA profile, which could be increased. Next I tested PETG, which is harder to print quickly, but it still prints PETG faster than any other printer I own. This Benchy looks very good and printed in around 42 minutes. This is with eSun PETG and I did no tuning. I just used the built-in generic PETG profile. Creality supplies a glue stick with the printer and the build plate recommends using it for every print. I didn't find it necessary for PLA, but I did use it with PETG, more to help release the print. PETG can stick too well. I used Prusa's material guide, which I'll link to below, to remind me when it's recommended to use glue stick or a similar product. This is not usually for print sticking, it's to make sure you don't tear up the build plate releasing them. I find 3D lac spray easier to apply and less messy. I also have the textured PEI sheet from Creality, which is better for PETG, and worked well with a few more test prints I did. Flex or TPU would also be better with a textured sheet, but I didn't have it for my first test print with this somewhat finicky plastic. I tried using some Filatech Filaflex 40 flexible filament to print a glue brush. I used the generic TPU profile, but it ran at too high speeds, resulting in a fairly major nozzle clog that was a real job to clean. Creality supply a useful long metal nozzle cleaner to try and clean any clogs, but I had no luck in this case, and if anything it made it worse. Even removing the nozzle, I couldn't clean the jam. In the end I removed the extruder and found a tiny piece of TPU blocking the path through to the nozzle. I used some cleaning filament to give everything a good clean and was back in business. I'll update the written review once I've got better results with flex filaments. It did at least give me a chance to delve deeper into the printer's construction. Creality have instructional videos which are helpful. I'll link to them below, but nozzle changes are a little awkward. They want you to remove the LIDAR sensor, hot end shroud including unplugging the part cooling fan, and then you have to remove the silicone sleeve, which was very fiddly to pull off without attaching any cables. It's a shame because in the latest Creality print they have support for 0.6 and 0.8mm nozzles, which I'd be interested in trying, but I can't see myself changing the nozzles very often. Whilst in the mood for taking things apart, I also thought I'd try and improve the bed level. The Creality web interface shows the bed level data, and my bed has a variance of between 1.2 and 1.6mm. Klipper should be able to handle this, but it's higher than I'd like. Creality outlines a procedure to reset the bed level, which I'll link to below. It's for the K1, but it's similar for the K1 Max. It involves moving the bed as low as it can go via the LCD screen, removing the bottom cover, releasing tension on the belt and tightening the 3 lead screws as far as they can go, pulling the bed as low as it can go. Then bolting it in place with the 3 transportation bolts before tightening everything back again. If you follow this procedure on the K1 Max, you'll need to completely remove the tensioner bolts. Even then, it's not easy compressing the spring to detach the belt, and even harder to get the belt back on again. Some of these parts feel very flimsy. The cheaply made plastic tensioner sits on small plastic rails, so be careful. I got almost no improvement doing this, so personally I wouldn't bother, unless advised by Creality. It wasn't particularly easy getting hold of support, but a support contact told me that anything under 3mm they consider absolutely fine. And to be fair, whilst I've seen far better first layers, my prints mostly came out looking good. You'll probably get better improvements for a high-speed printer like this tuning flow rates, as already discussed. Next I tried printing ABS using eSun ABS Plus and Creality's generic ABS profile. One big advantage of an enclosed printer like this is being able to print tricky filaments like ABS and polycarbonate that like steady warm temperatures without any drafts. I used Dymafix instead of glue stick since ABS likes to warp and this holds it tightly to the bed and releases it easily once the bed has cooled down. I did slightly alter the generic profile. I made the part cooling fan only come on at layer 4, not layer 2 as set in Creality's profile, to avoid any delamination. Everything I printed came out looking good, and with a carbon filter I didn't notice any unpleasant smells from the ABS. Finally I printed Polymaker's Polymax PC to print a tiny spanner and hex bit holder to change the elements in my dualit toaster. These printed nicely with no issues, and with their heat resistance can be stored in the crumb tray of the toaster. With a reverse Bowden setup, if you print hygroscopic materials like this, you can print straight from a dry box or filament dryer to prevent your filament from absorbing any moisture even on its path to the extruder. For ABS and polycarbonate, the heated bed has to heat up to 100 degrees centigrade or higher. Typical DC heated beds can take a long time to heat up. The AC heated bed on the K1 Max heats up very quickly. It gets to 60 degrees Celsius in just 40 seconds, 98 Celsius in 2 minutes 20 seconds, although it did take a further minute to get to 100 degrees centigrade in 3 minutes 16 seconds. In comparison, my Prusa MK3S Plus took well over double the time to get to 60 degrees centigrade and 5 minutes 28 seconds to get to 100 degrees centigrade. Checking with a thermal imaging camera, there is quite a drop off in temperatures away from the centre of the bed, although the Prusa is only a little better. The nozzle heats up quickly too, but starting a print is still quite slow. It varies, but it takes a minimum of 4 minutes before a print starts, and at least double that with AI features turned on. Homing and nozzle cleaning take over 3 minutes, then the bed levelling routine checks the 4 corners to see if a full routine needs to be run. If the 4 corners match the existing levelling mesh data, it continues with the print. I mentioned earlier that Creality now allows root access to the printer, so you can configure the printer how you like. I'll provide a link down below with detailed instructions on how to do this, and the files and tools you need to download, but it's fairly easy. Download the firmware and the fluid folder to a USB stick. Turn on the printer with this USB stick inserted and accept the prompt to install the update. Make sure you complete the input shaping and levelling routines as prompted. To install the Fluid Web interface, which allows far greater control and access to all the config files, enable root access from the LCD screen and take a note of the password. SSH into the printer using something like PuTTY, using the printer's IP address, and log in using the password you just noted down. With the USB stick inserted, type the following commands which are on screen and down below to copy the fluid.sh and fluid.tir files across. Then install the Fluid interface using this command. To access this new interface, just type the IP address of your printer followed by :4408. Go into Settings Camera to add the built-in camera. Now you can print directly from, say, Orcaslicer or any slicer of your choice. If using Orcaslicer, the default profiles are quite slow. I'll provide a link I found to some faster profiles that compare to Creality Clouds. If you want to get adventurous, I'll provide a link to an easy setup guide for KAMP, which generates a levelling mesh only for the area of the actual print rather than the whole bed. I only got this to work with Orcaslicer though, but it is a great add-on. So is the K1 Max the 3D printer I've been waiting for? In a lot of ways it is. There's no complicated assembly, no worrying about Z offsets, it's fast and it can print pretty much any material that is readily available with its enclosed design. And it has Ethernet, Wi-Fi and a webcam built in, which makes sending and monitoring prints a breeze. I've been printing with this machine non-stop since I received it, and it's mainly been a good experience. I usually printed using the fastest built-in profile in Creality Print, and although prints aren't perfect, they're mostly pretty good, and I had very few failures. There are still some artifacts from vibrations, and I get better first layers on most of my other printers, but then it is super convenient not having to think about Z offsets. If you want better overall print quality, you can always slow things down. I did have trouble printing flexible filament with a major nozzle clog. More worryingly, on 2 occasions, inexplicably, the nozzle rammed into the bed during levelling, the second time pretty much destroying the flexible sheet. Nozzle clogs do happen, but the nozzle crashing into the bed is not good. I did eventually get hold of Creality support, who are sending a new PI sheet, but they didn't have any good explanations for what might have caused the crashes. There are a few minor issues I also found with the printer. The cabling looks very neat in its drag chain enclosure, but it catches on the pulley mechanism at the back left of the machine. I printed some clips to attach the PTFE tube to the top of the drag chain, which mainly avoids this issue. Also, the bend in the PTFE tube rubs on the glass lid with it in place, which is not ideal. This bend also causes a fair bit of friction for the filament to overcome. I didn't actually notice it causing any issues, although it probably didn't help printing the TPU. Feeding filament is a little fiddly, partly because of this resistance, but also sliding in through the filament runout sensor often takes a few attempts. I was also a little disappointed with the bed level. Unless you're very lucky, there'll be a 1 to 2 mm variation across the build plate. Klipper will compensate with this to a degree, but it's not ideal. There are various suggestions on Facebook groups and Reddit on how to try and fix this, but be careful you don't end up making it worse or damaging your printer. For most prints, it really doesn't matter. Lastly, I wasn't convinced by any of the AI features. I'm hopeful Creality will update the firmware to make the most of the hardware, but for the time being, I wouldn't buy the printer based on its AI features alone. If they improve it, I'll do a follow-up video. Despite these mostly minor criticisms, overall this is an impressive, capable, fast 3D printer. It's going to be hard printing on anything else now. You can check the current price and any discount codes I have down below, but whilst not cheap, the price is competitive. Only my FLSun Super Racer Delta printer, also running Klipper via their speeder pad, comes close speed-wise. The FLSun is quieter though, and prints start a lot quicker since it only needs occasional levelling with a stationary bed. The K1 Max's main competition is the smaller and cheaper K1 if you don't need the extra size, but I'd recommend adding the optional camera. A lot of the K1's initial teething problems seem to be now fixed. Another option if you don't need the size of the K1 Max is the Bambu Labs P1S, but I've not tested that one yet. I'd love to hear your thoughts. Are you considering this printer, or if you already own one, what do you think of it? Please let me know down below. And as always, if you have any questions, please ask. I read every comment and will do my best to respond. I do hope you found this video useful. Please like the video if you did. I'm releasing videos every week on the latest technology and how to get the most out of it, so please make sure you subscribe. And don't forget to tap the bell icon if you want to get notified as soon as a new video gets uploaded. Thanks for watching.